Okay, good morning. So I decided to continue with the natural continuation of vectors for at least 2 or 3 sessions. That's good to know about this because what we have started you can consider as part of a course called linear algebra, and the continuation, natural continuation of linear algebra would be talking about planes and lines in space. Okay. Okay. So let me start. In principle, I should start with lines and then planes. But I think from pedagogical point of view, I would rather to start with planes in a space rather than lines, because algebraic problems that will occur in lines is a little bit more involved than the planes. Yes. So even though a line is a simpler object than a plane, but as you will see, if you want to write an equation of a line in a space, it would be harder than writing an equation for a plane in a space. Not harder, I mean it needs some technical problems that we need to learn. So I want you to help me actually to start this new topic together. Okay, so the first thing we want to do, what is the first thing we want to do? I have a coordinate system consisting of x, y, and z axes, and then you give me a plane. What is the natural starting question here? Yes?
A plane that is on the same plane as two of the axes.
Oh yes, of course. No, I'm not talking about that. If you want to start this topic of planes analytically, what is the first step to do?
Finding the equation for it.
Exactly. So I need to find an equation for the plane, or all the planes in a space. Yes, is that clear? So that's the first natural step. I want you to start thinking, because now you have nearly really good knowledge about mathematics if you really value it. So I mean that if you are a mathematician and you want to talk about planes in a space, analytically, the first question that you need to answer is that what is an equation for a plane? Yes, and then we want to answer that question. Okay, how do you think about this? First of all, you need to understand what is the meaning of an equation of a shape. If I have a sphere, if I have, I don't know, some strange shape in a space, when I say this algebraic equation represents this shape, what do I mean? These are very generic questions, because now you are specializing in mathematics in this course. I want you to really appreciate these things, because this will actually help you a lot in your future courses if it is somehow related to mathematics. So what do I mean by an equation of a shape? For example, even in Math 1C, if I have 2 dimensions, just consider a very, very simple setup, yes? Just in Math 1C, and I draw this line, the bisector, and hopefully you know that this is represented by this an equation. What do I mean? Because you know that if I say, what is this? This is a geometrical object, and that is a line. And if I ask you, what is this? It's quite different, yes? It is an equation which lives in algebra. And this is an object, geometrical object, which lives in geometry. But we are telling that this equation represents this shape. What do we mean by that? You should be able to answer this, yes. When we say y equals to x represents this line or this shape, what does it mean? It means that any point that you choose on this line has 2 coordinates, x and y. X and y coordinates of this point are the same. Yes? And vice versa, that is also important. If somehow you come up with a point whose coordinates are the same, it lies on this line. So that is the meaning of writing an equation of any shape. Yes? Okay, so now let us go to 3 dimensions and talk about the plane. So, for example, let me just draw 3 coordinate axis. And then you remember, we always work with the right, I forgot the name, do you remember what was that? So I mean that x should be here, y should be here, and z should be here, in a way that when you rotate the x-axis to the y-axis, your right-hand thumb should point to the z direction. What was the word? You remember?
The right hand rule?
No, that's the right-hand rule, but that's not the right-handed coordinate system. Yeah, so that's called right-handed coordinate system. Okay. So I always work with a right-handed coordinate system. So it is important. You choose whatever you want for x, you choose whatever you want for the y direction, but then you have to respect the right-hand rule for finding the direction of z. Okay, and then I give you a plane here. So let me just draw some plane here. Of course, by the way, this is not a real plane, yes? I just draw a parallelogram, but you know that a real plane doesn't have any borders. So if you have a plane, it cuts the universe into two parts, yes? And so it will continue forever. So even you don't know if the border is a straight line or not, we don't see the border, guys. Okay, so now we want to find an equation for this. Okay, how do you think about the problem? First of all, what do I mean by finding, again, I want to repeat the question, what do I mean by finding an equation for this shape? What does it mean? Yes?
That every point on the plane satisfies the equation and every...
Okay, so you want to find a relation among the x, y, z coordinates of all the points on the plane. Yes? And you cannot, of course, start with all the points simultaneously. So what you take a representative here. I would say that let A be a point. Let me call it here. Let me write A, be a point with coordinates x node, x, y, and z on this plane. And if you don't mind, let me call the plane P. Yes, so I think it's not a good way of notation. So that I don't want you to confuse it with vectors. So that's a point on this plane. The coordinates are x, y, and z. If I can somehow find the relation between x and y and z, then I am done. Yes? That's the point. When I ask you to find an equation for a shape, you take a representative point of your shape and try to use the geometry of the shape to connect x, y, and z together in one equation or more. Yes, that is the equation of your shape. Okay, so how do you look at the problem? We want to find the relation among x, y, and z. Yes.
Because the plane doesn't have a volume, one of them should be the same.
No.
Shouldn't
The x, y, and z are coordinates of the point. Do you understand what I mean? There is no guarantee that two of them should be the same. Do you understand that?
No,
Because this point is free to move around this plane. I'm just taking one representative point of that. If there might be some points whose two coordinates are the same.
No, I didn't mean two coordinates.
Mhm.
I mean this plane isn't parallel to any of the axes.
No, not
But if you
in general.
create a plane
Yeah,
that would be parallel
to one of the
them,
axes, then.
that point would be the same for all points, and you would make the problem easier for yourself.
Yes, you can make the problem easier to yourself, but you need to solve the harder one now. Yes, because even if you are true, but so that is not completely correct what you said. But even if in that case we were able to do something like this, it means that we can only find equation for those planes that are somehow parallel to one of the axes. And then of course you know that these are not the only planes. For example, the plane that I have drawn here is not parallel to any one of these axes, yes? And then the question is that, okay, what's an equation for those planes? Okay, so let us start and tackle the generic problem. But the way that you are thinking is still missing. So, okay, I want to find an equation of this plane. Yes? What is missing? Yes?
I mean, if you take 3 points in the plane,
Yeah?
maybe then you can figure out.
No, before that, there's something missing. Very, very trivial thing missing. So let me ask you this question. Can I ask you this question in Math 1C? Write an equation of a line. Do you write it? Do you write it? No, the question is that which line? Because these are natural questions. I don't know, why don't you ask me, yes? When I ask you to write an equation of a line, the natural question is that, okay, Babak, which line do you mean? Yeah, that's exactly the same question you need to ask. I have drawn some shape here, but I didn't specify which plane is this damn plane, yes? Because how many planes are there? Infinitely many. If I want to write an equation of one plane, so I need to tell you which plane. Yes? Then, of course, you might be able to write it or not. But at least I should tell you, okay, write an equation for this plane. Yes? Of course, the equation of this plane might be different from the equation of that plane, because they are different. Yes? So, okay. So this means that the first thing is that which plane? So there are infinitely many planes. You want to specify and single out one of them. Then you need to think like you. One way to single out a plane is what?
Taking 3 points.
Taking 3 points. Is 1 point enough? No, yes, because if I just give you 1 point, so of course this is not a good, this is not a plane because it doesn't continue forever, but if I tell you that a plane that passes through this tip of my finger, this is not a unique plane, yes, and many of these planes are going, so which one I mean is not clear. Is 2 points enough? No, because if I give you 2 points, you see, for example, consider these 2 points, all these planes are passing through those points, so it's not enough. And then what you said, 3 points that does not lie on the same line will be enough to specify one unique plane. Yes? Even though that is true, but we do not have enough tools in our hand right now. I want to change my strategy. That is one strategy. If I want to give you, if I ask you to write an equation of the plane passing through 3 points, in principle you should be able to write it. Because by giving you 3 points, I am singling out exactly one plane. Yes? Even though that's correct, this is not my starting strategy. Yes?
You can represent it by 2 unit vectors.
How?
I don't know how, but if you have 2 vectors like this, they create a plane,
Yes?
and then you add them together, you can scale them, and then you will get 1 point
on the plane.
Yeah.
That's very good. That's also a very nice strategy. I will not follow that one as well. But that's correct. We will come to that because I have to decide either I should go with that one or with that one or with another one that I want to go. But I will choose the one that I want to go. Then you can get those things from that, okay? Or I could use yours and then you have to get mine from that. But I think from pedagogical point of view, another one is easier. So let us think in this way, okay? How many degrees of freedom a plane has, yes? The plane can rotate around, yes? The plane can go up and down. So I can translate planes, I can rotate the planes, yes? So in principle, if I want to single out exactly one plane out of infinitely many, I need to kill those degrees of freedom. I shouldn't let the plane start rotating around. I shouldn't let the plane go up and down, being translated, yes? For killing the translational degree of freedom, 1 point is enough, more or less. Yes, because if I ask you what is the plane passing through this point, then this plane is not one of them. This plane is not one of them. But still there are infinitely many planes because all these planes are passing through this point. So, but this 1 point more or less kills the translational degree of freedom. Yes? But how can I kill the rotational degree of freedom? I shouldn't let my plane rotates about that point. Yes? How can I do that? By giving a normal, by giving a perpendicular vector to this. Is that understandable? So I can say that the plane that passes through this point and is perpendicular to this vector. Then it is fixed. Understandable or not? You need to have a little bit of geometrical intuition, yes? Is that clear? So let me just do it around. So if I want to find a vector perpendicular to a plane perpendicular to this is not one of those planes. Yes? All of these planes are like that. All of them are perpendicular to this vector. And for killing the translational degree of freedom, I give you a point. Then it becomes fixed, one single plane. Is that right? Okay, so for specifying the plane, I need to give you two pieces of information according to what I described. I need to give you one point. I need to give you a vector which is perpendicular to the plane that I am interested in. Is that right? Okay, so let us just put these information in this picture. So what I say is that let me call this vector n, normal vector. Every vector in the previous chapter we learned that it has three components. So let me call them A, B, and C. Yes? So if someone asks me what is this, I would say that this is a normal vector. I cannot cite, by the way, I cannot call it the normal vector because I can make it shorter or longer. I can even change the direction at the tip of the arrow. It remains perpendicular. And do you agree that according to intuition that we have, every one of them are actually equivalent for me? Yes, it doesn't matter. The length of this vector and the direction of this vector doesn't matter. Only thing is that it should be perpendicular to my plane. Okay? Okay, now this is the typical point. So this is given to you. Be careful. I want you to understand. A, B, and C are given to you because you want to single out. One more thing is given to you. Another thing that is given to you is that you know point M with coordinates X node, Y node, and Z node. I want you to understand it. So if I ask you to write an equation for this plane, I have to specify the plane. Now I have already specified that. I am saying the plane that passes through this given point and is perpendicular to this vector. There is only one plane with that property. I am looking for the equation of that single plane. Yes? Now everything is ready. Now I can ask you, okay, how I can find, don't lose the logic. What was the logic? This is a representative point of my shape. I have to use the geometry of the shape in a way that I can connect X, Y, and Z together. What are the information given to me? A, B, and C are given. X node, Y node, and Z node are also given. Using them, I want to connect a relation between the coordinates of that representative point, X, Y, and Z. Yes? So now everything's settled down, we have to do the algebra. Okay, how do you think I can find the relation between X, Y, and Z? So now geometry comes in. So you need to use the properties of the plane intuitively and find the connection between X, Y, and Z. So you see, this is the normal. So consider this is your plane. This is the normal vector, okay? And there are 2 points. One of them is A here, and the other one is M here. So what is the relation between this vector and this vector? It's not good in my picture, but it is very easily seen here. This is the normal vector. I have 2 points here, one here, one there. Yes? And then I connected them. Yes? And make a vector out of it. What is the relation between this vector and that vector?
The cross product is 0.
The dot product
The
is
dot
zero.
product is 0.
Yes, why?
Because they're perpendicular.
Because they are perpendicular. So you see, this is, by the way, important. This point and that point they are on the line, on the plane. The whole line will lie on the plane. That is the property of flatness of a plane. If I have 2 points on the surface of a sphere, if I connect them, this line will not lie on the surface anymore. So I am using the flatness property of a line, of a plane, yes? So this, we would say that, okay, M belongs in the language of set theory, M belongs to the plane, A also belongs to the plane, yes? Then what can I conclude? I can conclude that vector MA is a subset of the plane. Yes? So it means that it lies on the plane in the language of geometry. Okay, and then because n is perpendicular to the plane, MA is also on the plane, so I can conclude that n is perpendicular to MA. Yes? And I told you that you need to make your brain conditional. Whenever two vectors are perpendicular, you need to remind yourself about the dot product. Yes? So this means that the dot product is 0. Yes? So, the dot product is 0. But do you remember what is the dot product? First of all, can you tell me what are the components of vector MA? Don't get confused. These are the coordinates of the point. These are the coordinates of the point. But for be able to write the dot product, I need the components. A, B, and C are components of this vector. So what are the components of MA vector? These are famous things in this course. This should be a matter of milliseconds to write it for me. So what is MA as a vector? No, that the square root is the length.
Okay.
I need components. In this course, I really expect you to differentiate between the coordinates of points and components of vectors. Both of them are shown by triples of numbers, yes? But you remember that is more or less the length of the projection of this vector onto the axis, including the direction, yes?
0 plus x.
No. This is extremely important. If you haven't, so please send it to your memory now. This is the final point minus the initial point. So this becomes what? X minus x node, y minus y node, and z minus z node. If you have forgotten y, go back and check it out, because that is good for your memory. Yes? This is good. You know, whatever we learned in the previous topic for vectors, we will definitely use them here. Somehow it's a good playground for you to understand these things deeper. But that's MA, yes? And then do you remember the formula, analytic formula for the dot product if I have the components of my vectors?
You just multiply the components.
Case by case and add them. Yeah? So what I do, the components are A, B, and C. The components are x minus x node, y minus y node, z minus z node. So what I do, I would write A multiplied by the first one, plus B multiplied by the second one, plus C multiplied by the third one, equals to 0. Yes? Is that understandable? Okay, then what? Then what?
Expand.
Do I need expansion?
Oh.
Yes, you are right, I can expand, but in principle the problem is finished. I want you to understand the problem is finished.
Oh, yeah.
Yes, do you understand the problem? These are important questions, by the way, I am asking. Do you understand the problem is finished? Yes or no? What was my goal? My goal was to find a relation means equation, between x, y, and z, connecting these x, y, and z to my information that I have. And I got it. So this means that whatever this number is, these numbers is, they should satisfy this equation. And that's exactly the equation that I was looking for. Yes? And this is, I hope that you memorize from now on. Try to memorize things, okay? Sooner or later, in 2 or 3 months, you have to start memorizing all of them. Okay, so this is actually an equation. An equation, why I say an equation? Because I can multiply this by 2. I can multiply it by 3. I will change the equation, but of course, it will be the same plane. So this is an equation of the plane that passes through this given point and is perpendicular to this vector. Yes? This is something that you need to know. Exactly like this equation in Math 1C. This is an equation for the straight line that has y-intercept m and has a slope k. And more or less in the same way, this is an equation for the plane that passes through this given point and is perpendicular to this given normal vector. Yes? That's clear. So this you need to memorize. Whenever, from now on, whenever I ask you to write an equation for the plane, your brain needs to start searching for two pieces of information in the problem. One piece of information is try to find a point in the problem which you are convinced is on your plane, and then convince yourself of a vector that is perpendicular to your plane. And that is the important thing for the normal vector. Does the length matters? No. You see, the length of n doesn't involve itself here. I just use perpendicularity. And so if you see, if I make this vector shorter, still this relation holds, and I will get the same thing. Even if I interchange the direction, point it downward, then still this relation holds, and then this would be the same equation. So you see that it doesn't matter the length of this normal vector. So to make your brain conditional, when you see in a problem you are supposed to find an equation for the plane, try to look for two things in the plane. One point that you are convinced is on your plane, a vector somewhere around in the problem that you are convinced is perpendicular to your plane. And then you have to have this formula in your head and put the numbers there and you get it. Yes? Is that understandable? Yes or no? Okay. So I hope that you see what is going. For example, I don't know, if I just want to give you a very, very simple question. If I give you point A to be 1, minus 2, and 3, and if I give you the normal vector to be minus 1, 0, and 2, then what happens? Then I put minus 1, x minus 1, and then I put 0, y minus minus 2, and I put 2, z minus 3 equals to 0. Of course, I would prefer to simplify because I have numbers now instead of this. So it becomes minus x plus 1. This is totally vanished. And then I will get 2z minus 6 equals to 0. And then I would, for example, usually people write it minus x plus 2z and then move the constants to the other side, which becomes 5. So that is an equation for the plane. And I think it is, I will try to, next time that we are in yellow, we can use three-dimensional graphics of GeoGebra to draw these graphs and see that they are really making planes and things like that. Is that clear? Okay? So let me ask you one question. I want you to solve this one for me, okay? It's very, very simple. The example. The plane that passes through the point A, 2, 1, and 3, and is perpendicular to the vector n equals to 2, 2, and minus 1, intersects the y-axis at the point B. Determine B. Yes, it's a very, very simple problem. Yeah, I pause recording so that you can solve this problem. Very simple problem. Okay, could you find it? Yeah? So what is the first thing to do? First of all, I need to find an equation for this plane. So the plane passes through this point and is perpendicular to that one, so I immediately find an equation. How should I do that? You remember A, B, and C are the components of your normal vectors, so 2, 2, and minus 1. And then you need to write x minus the x coordinate of the point plus 2 times y minus 1 plus, which is of course minus 1 in this case, plus and minus, and then you have z minus 3 equals to 0, yes? That is an equation for your plane. Let us simplify it in our head, so it becomes 2x plus 2y minus z. The number minus 4, minus 2 is minus 6, plus 3 is minus 3. Move it to the other side, it becomes plus 3. Yeah, so that is an equation. And by the way, it's a standard form. Usually, if you want to write the K form, you can move z to the other side and 3 to the other side. Then you have z on the right, and then other variables on the left. Yes, but it's not necessary. Just write it like this. And then we want to. Then this, according to the problem, this plane goes and intersect the y-axis at a point which I call it B. We are supposed to determine B. It means that to determine the coordinates of the B. The coordinates of B, there are 3 numbers, x, y, and z coordinates of B. 2 of them are already, we know them, yes? What are they?
0.
0 is the x coordinate and z coordinate, but the y coordinate is missing. So I would say that, okay, this point B is something like this. It is 0 here, 0 there, but I don't know, let me call it alpha here. But the only thing that I need to find is alpha. But again, the same rule in mathematics, we know that this point also lies here. So it means that the coordinates of the point should satisfy that equation. So I would, instead of x I put 0, instead of beta I put, instead of y I put alpha, and instead of z I put 0 equals to 3. And then I immediately get that alpha is 3 over 2, and then put it back here. Yes? Okay, let me ask you another question. Let me not write these things formally because these are very simple questions. So, if I want to find an equation for the plane that passes through this point and is perpendicular to the y-axis, passes through this point perpendicular to the y-axis. Okay. How can I write an equation for that plane? Again, I want you to make your brain in a conditional situation. You are supposed to find an equation of a plane. So you need to search for 2 things. One is a point that is on your plane. You don't need to look for it. It is directly given. And then another thing that you need to look for is a vector, somehow, that you can convince yourself it is perpendicular to the plane that you desire to write this equation. What is that? So what is that vector? Any vector that is perpendicular will work. There is no best vector. Yes? You just need to find which one is that vector. Yes?
I mean the unit vector for...
Yeah, the unit vector for y. What was the name of that? J. And it was 0, 1, 0. Is that understandable? Because if this is the y-axis and my plane is supposed to be perpendicular to the y-axis, it is automatically perpendicular to the j vector. And any vector that you are convinced is perpendicular will work. Okay? So what I have to do, I will take my n to be j in this case. Yes? And j is 0, 1, and 0. And then I put these numbers into the formula that you're supposed to memorize. 0, x minus 1, plus 1, y minus 2, and then plus 0, z minus 3 is equal to 0. This is vanished, so what I get is y plus 2 equals to 0. And I intentionally write it in that way. I want to emphasize something. Y equals to minus 2. Yes? That is an equation for that plane. It's a little bit surprising because in Math 1C, y minus 2 is what? Is a line. Yes, which is horizontal line. But be careful, identical equation in a space becomes a plane, not a line. And that is clear because in two-dimensional case, when I write y equals to minus 2, I have 2 degrees of freedom, x and y coordinates. By giving you y equals to minus 2, I am freezing 1 degree of freedom, so there is 1 degree of freedom left. Yes? So that is one line. But here, that's the same equation, but now I am in a space, there are 3 coordinates, there are 3 degrees of freedom. This is only freezing one of them. And then 2 of them are left, so I am moving in a two-dimensional object. Yes? And that means, but of course I have shown that first degree equations are planes, and then that should be a plane. Yes? Do you understand that? That is a plane. And if I want to, by the way, you can also solve it completely different from this method. So I don't know if I can draw it x. Okay, so let me just draw something like this. This is the x, y, and z coordinates. I want you to understand this way as well. So this is the point A1, minus 2, and 3. Where is that? The x coordinate 1 unit. Yes? And then I go 2 units here. Yes? And then I go 3 units up. Something like this. So I want to have a plane. If you see this dotted line, assume that this is the dotted line. And this point is somewhere here. I want to draw a plane that passes through this point and is perpendicular to that one. Yes? Do you agree that you don't have any control on x and z coordinates? They can be whatever they want to, but the y coordinate should be minus 2. So that's the only constraint that you have for such a plane, and y should be minus 2, regardless of the values of x and z. Yes? Understandable? Because when you have, this is the y-axis and it's perpendicular to this, every point that you have here can have any x and z that they like. But they cannot have arbitrary y. The y should be minus 2. And that's exactly the same. Is that clear? Yes or no? Okay. Now let us go back to your question, to your, what Dimitri said. Now I'll give you 3 points. In principle, we know that this is possible. If I give you 3 points and I say that write an equation for the plane passing through these points, you should be able to do that because there's one single plane. And in principle, we should be able to find that. So let us solve it together, okay? And let me choose these numbers so that if you can give me the answer, I can immediately realize that. Okay, that's true or false. Because I want to stop and wait for you, okay? So I give you 3 points. Let me choose exactly the numbers that I have in my notes. So 1, 1, 2. And then 3 minus 1, 2. And then C is minus 2, 1, 4. I am asking to write an equation for the plane that passes through these 3 points. And that is my responsibility to make sure that these 3 lines don't lie on the same line. Because if accidentally they lie on the same line, can you answer the question then? There is no unique one. There are infinitely many planes passing through these 3 points. Yes? I have already checked that they are not lying on the same line. So in principle, you should find an equation for the plane that passes through these points. I want to give you 5 minutes and I want to pause recording because I don't know how many formulas and things do you remember from vectors. Do you have the answer?
Yeah, I think so.
Yes, please.
So 2x plus 2y plus 3y equals 10.
Plus 3z equals to 10.
3z, yeah.
Yeah, that's correct. So that's the answer. Thank you. Okay, so let me just try to explain it once more. So you see, I have asked you to write an equation for the plane. When you reach here, your brain should look for 2 pieces of information. One piece is find a point on the plane. Instead of 1 point, you have 3 points here, so you don't have any problems there. And then you need to look for a vector somehow that is perpendicular to your plane, which is not directly given here, and that's your responsibility to find it out, yes? So what you do, you can just go to a scratch paper and try to sketch something for yourself. Assume that this is the plane which is missing. You want to write its equation, but you know that the points A, B, and C somehow lie there. So I need 1 point. I have 3 instead of 1, so that's good. I don't need to be worried about that point. And I need to find a vector that I can convince myself that is perpendicular to my plane. In which direction it lies, how long it is, we don't care. Yes? Okay, now Ruben, can you tell me what did you do?
2x plus 2y plus 3.
Well, can you tell me what did you do?
So I took I created 2 vectors, a, b, and then ac.
Exactly. So you created vectors AB, because A and B are on the plane, definitely AB lies on the plane. The same true for AC. Yes? So I have this is the plane, this is the one vector, this is another vector there. They lie on the plane. Then
I took the cross product of them.
the cross product. Does it matter which one cross product, the other one? Of course it matters for the sake of the cross product, but for the sake of my problem it doesn't matter. Because if I cross product AB by AC, it will go down. If I cross product AC by AB, it will go up. But in both cases, the vector that I generate in that way will be perpendicular to my plane. Is that understandable? Because that cross product will be perpendicular to AB and AC. And then it means that it will be perpendicular to my plane. So, okay, that's completely correct. So let us just do that. For example, here, let me write AB. AB is the final point minus the initial point. So this becomes 3 minus 1. And then it becomes minus 1. Please correct me if I am making mistakes in my calculation. And then 2 minus 2. So if I simplify that, it becomes 2 minus 2 and 0. Yes? And then AC. What is AC? The final point minus the initial point. So it's minus 2 minus 1, 1 minus 1, 4 minus 2. So the answer is minus 3, 0, and 2. Yes? Yeah? And then I cross product them. When I cross product them, I will get a vector which is the normal vector. So this means that one normal vector, a normal vector can be AB cross product AC. Yes? But one question, can I divide here everything by 2 and then do the cross product? Yes or no? I want you to understand this because sometimes you can simplify things. So you see this is divisible by 2, divisible by 2, divisible by 2. If someone divides everything by 2 and then do the cross product, of course I will not get the same vector back, but does it matter for my case? What I am doing, by dividing this by 2, I am making this vector shorter. Of course it will affect the length of the produced vector, but it will not affect the direction, and what matters for me is just the direction. So be careful. For example, if these numbers are very 2 square root of 2 minus 2 square root of 2, instead of working with the square root of 2, you can get rid of the square root of 2. Yes? Have these things in mind. And then I don't know why did you say it takes a long time. I told you the trick. If you want to cross product, then write the first one above, the other one below, and then cover the first one and do this cross product way. Minus 4 minus 0. Yes? So it is minus 4. That's simply as that. Yes? And then you take the middle one and multiply this by that, 4. This by that is 0. It becomes 4. But do you remember? There's one point to remember. The middle one has an extra minus sign. Yes? And then the last one is 0 minus 6. Yes? Yes? I can work with this one, but can I divide everything by minus 2 and work with that one? Of course, this is the vector n. I will get another vector n1. I divide everything by minus 2, it becomes 2, 2, and 3. Do you agree that I can work with this or that? It doesn't matter. They are not the same vectors, but because one of them is a multiple of the other one, they are lying on the same direction, and that matters. So I would prefer to work with the simpler one. Okay, so what I do, I would write, do you remember the formula now? So 2x minus another 2 y minus another, so now 3 z minus equals to 0. So what do you put these for these empty spaces?
Any point on
Any point. And if mathematics is consistent, it doesn't matter. Okay? You can, I don't know which one you used.
I took A.
You took A. So let me take B to see that the answers will be the same. So this becomes 3, and this becomes minus 1, and then this becomes 2. Yes? But let us calculate. This becomes 2x, 2y, and 3z, as Ruben mentioned. Hopefully this becomes 10 again. So it is minus 6 plus 2 is minus 8. Oh, it's not. You said 10?
Yeah, 10. This is
Yeah, it's also 10 here. So but why is it wrong? Let me double check. Minus 6 plus 2. Minus 6. Yes, that's correct.
Yeah.
Minus 6 minus 12 plus 2 is minus 10. You said that you moved it to the other side, it becomes 10 again. So it doesn't matter which you use, and that's good, because otherwise mathematics is consistent, and I don't know how I need to live then without minus. Okay, so this is correct. Okay, one more thing. So let me do some experiment to see that you understand exactly. Then I want to change the topic a little bit to do some algebra before continuing a little bit further. So if I ask you this question, how do you solve this one? Write an equation for the plane that passes through these 2 points. A is 1, 2, 0. B is, oh sorry, you don't need to put equality. B is 0. I want to keep the numbers the same so that if you can solve it, I can recognize it. So I want to find an equation for the plane that passes through these points and is parallel to the y-axis. And parallel to the y-axis. My plane is supposed to pass through these points, but in a way that it becomes parallel to the y-axis simultaneously. So I want to pause recording again and wait for it. Yes?
No, I just have a question.
No worries.
So the plane is supposed to be parallel to y-axis.
Yes. So there are 2 points.
Yeah.
The plane is supposed to pass through this, and I don't know if this is the... So you know that if I have 2 points, there are infinitely many planes that can pass, yes? If I give you 2 points, and then you need to choose one of them which is also parallel to the y-axis. Then it becomes unique.
I thought of the plane of y.
No. The y-axis. The plane might not contain the y-axis, but it is just parallel. Okay, sorry for the interruption. Let me test your understanding. Before doing any calculation, one of these variables will definitely be missing from your equation at the end. Can you predict which one and why? So I'm saying that even without calculations, you should expect that one of these variables will be absent for this case at the end. Can you predict which one and why? The which one is clear?
No.
Yes, which one? What do you guess at least? Y, yes? Because if you say X, I would say that Y knows Z. Yeah? That's the same thing, yes? If you say Z, I say that Y don't say X. Because there is something particular about Y, not about X and Y. So, yeah, Y will be missing, but without calculation, can you visualize Y? This is important. I want you to develop these visualizations, skills for visualizing things. Look at my hand. So assume that this is the y-axis, and this my hand or one of those planes. All of them are parallel to this one. Yes? But there is, all of them share some property regarding to its normal vector. So if my hand is the plane, what is the normal vector to my hand? What is the relation of the normal vector with this y-axis?
Perpendicular.
It's perpendicular. Let me change my hand. I'm keeping parallelness, but I am changing the position of my hand. What is the relation between this normal vector and this one again?
Still.
It's still perpendicular. So you see that all of these planes, they are parallel to the y-axis, but the normal vector is perpendicular to this one. Okay, now tell me, if I ask you the normal vector it has three components, but which one of these components is 0 here? No.
No, wait, all of them.
No, this, which one? Because you told me that all these, so these are the normal vectors. I wish to have three hands, yes, but I don't. So if this one is the normal vector to the plane, it's also normal here. It's perpendicular here. If I change my hand in a way, it's still perpendicular to this one, okay? And then what happens? What was the interpretation of A, B, and C for a vector? They are the shadows of the vector on the x, y, and z axes with considering the direction. If I have this vector, the projection of this vector onto this is what? 0. So it means that y component is 0. Y component of the normal vector. And if the y component of the normal vector is 0, this is 0. And in the standard equation, you have x, y, and z. This is 0. So there is no chance for y to appear. Is that understandable? I want you to understand these things. So this is, if you have forgotten, let me mention. If this is the x-axis, and this vector is perpendicular to the x-axis, where I don't know, everywhere, because there is no location associated with the vector. So if this is the x-axis, the x component of the vector is 0. If this is the y-axis, the y component is 0. And if this is the z-axis, the z component. So remember these things. They are very helpful when you actually want to visualize things. Okay, I don't distract you anymore, sorry. You have a little bit of time. I'll pause recording the video and wait for you. So let me ask you something. So might be that is my recommendation for you. Don't try that hard to even visualize, because it is good to visualize it, of course, but it becomes a little bit harder. What I want you to understand, let me just tell you something. If this is a line and this is a plane, this line is parallel to the plane. Yes? There is difference between this shape and if I move this line here. Yes? Because lines have locations. This line is different from that line. But if this is a vector, there is no difference between this vector and if I parallel transport it here, if I parallel transport it here, or if I parallel transport it here. Yes? Understandable? So, when I say that my plane is supposed to be parallel to the x-axis, yes, unfortunately none of these things are actually being recorded, so it's a little bit strange. Anyway, so if I ask you, the plane is parallel to the y-axis, the plane is supposed to be parallel to the y-axis. So do you agree that my plane is also parallel to a vector, the famous vector of y-axis? What is that? J. But you can visualize J is on your plane. This I want you to understand, because vectors does not have locations. I cannot move the y-axis to my plane, but I can parallel transport J vector to my plane. It will lie exactly on my plane. Yes? And that becomes the same problem. Why? Because I already have 2 points A and B, I can make a vector, and the J vector, I can parallel transport it in my head to my vector. It becomes another vector. And then I cross product. I want you to think it in this way. Is that understandable? Yes? Otherwise, assume that this is point A, this is point B, and here is your vector J. But this situation for vectors is equivalent to this situation for vectors. Is that understandable? So I want you to understand this. Are you happy, Dima?
I think so.
Do you understand what I mean?
I think so, yes.
Because assume that this point, let me just be in this point. This point is A, this point is B. And then the plane is passing through these two, and then it's supposed to be parallel to the y-axis. Assume that this is J vector on the y-axis. In principle, if you draw the graph, you will see a situation like this in reality. Yes? But I told you there is no location associated for vectors. Even though we usually draw the J vector on the y-axis, but I can equivalently draw it from here. As far as I do not change the length and the direction and everything, it's the same vector. So from geometrical point of view, this problem is exactly that problem. Yes? So now can you tell me what is n then? So what I have to do, I have to find vector AB, but instead of having this to be, I don't know, whatever, I have J here somewhere else, somewhere here. But I can draw J again here, it doesn't matter, and then I cross product. Is that clear? So let us check. What is AB? AB is the final point minus the initial point, final point minus the initial point, and final point minus the initial point. Can I get rid of all these minus signs, yes or no?
Yes.
Yes, because I can multiply, but of course this is not the same vector, but who cares, yes? For my purpose, that's the same thing. Okay, so if you don't mind, let me write it BA so that I can keep everything the same. And then I have J vector, which is famous, 0, 1, and 0. I cross product them. So for the first one, 1 times 0 minus 2 times 1 is minus 1. Sorry, minus 2. The middle one has an extra minus sign, but it doesn't matter. And then what is happening? 1 minus 0. So do you see your prediction was right? This answer turns out to be 0. What you predicted, it should be 0. And it is 0 by calculation, yes? So then what you write minus 2x. And for example, I choose this point. I could equivalently choose this point. So this becomes x minus 1, and then 0, y minus 2, and then plus 1, z minus 0. So it becomes minus 2x plus z plus 2. I move it to the other side, minus 2. If you don't want to multiply by a negative sign, it becomes 2. So 2x minus z equals to 2 is the plane that I am looking for. Any questions here? Yeah, I think it's a good point to stop, but of course the plane, I don't know, 1 or 2, yeah, I think 2 more sessions we will talk about the planes, and then we go to the lines, and then probably we'll switch the topic again, okay? But that is good to understand these things as well, okay? Any questions? Thank you very much.